Welcome, and today we're going to be looking at basic accessory control using nowRail. So let's have a look what's going on the desktop. So here we have something that looks a bit of a sort of wiring nightmare, but ignore the servos. I'm running out of breadboards at the moment, so I'm having to use double up on the boards. So we've got an ESP32 in the middle. I have an LED here and here that are connected to some pins directly to the ESP32, and then I also have a shift register that you can hardly see through the wiring. It's one of these, and I'll explain that a bit more. And then off that shift register I have 4 LEDs running, then I have 2 relays and 2 MOSFETs. And the reason for this is for accessory control. There's 2 types of things that this could control on your layout. Obviously we could just simply turn some LEDs on and off in a building, but these are for controlling solenoid sort of point controllers, turnout controllers, so the sort of the snap type ones. And what you'll see if you watch carefully is as these get triggered, you'll see they're just pulsing for half a second. Now the reason for using a sort of a MOSFET or a relay setup is to shift those point motors, turnout control motors. It takes a lot more than the 3.3 volts that the ESP32 can deliver, and therefore in sort of the way I would build it was I would have a sort of capacitor discharge unit that is then triggering the solenoid through the relays or the MOSFET, depending what you want to do. So let's have a look and see how this is all set up. So going to the Digital Town website, to the nowRail page, there's a link below the video, and what we're going to be looking at today are standard pin functions and 74HC595N shift register pin functions. So let's go to standard pin functions first. So there is a pin function to add a button that I showed in the control panels video, and today we're going to be looking at adding the accessory. So let's get started. So I've started by taking a copy of nowRail, which is now up to 0.3, and I've resaved it as nowRail 0.3 AX. Just because we're going to do some accessories. So let's go down to the setup, and the setting up of these things is very, very simple. If we go to our item, we just take this function, copy it across, put the prefix on, and then basically we say which pin. So I'm going to choose pin 15. I'm going to let this control an accessory number of hang on, just got to check for the one that I've set up just to make life easier. I've already written some code that's triggering this, so we're going to set up an accessory number of 1000. Oops, not work very well. There we go. 1000, and I'm going to set it, this one, when there is a direction of 0 sent to this accessory, and for this one I want it to act as a pulse. So a pulse is used for these accessory decoders for the solenoid motors, and it basically sends a half-second pulse through. Now in the user setup you can change the turnout pulse to a different value if you want, but so we're going to use it to send a pulse, and I'm going to set that pulse so that it is high. So if I'd had this as a 0, the pin would have been set high the whole time and the pulse would have been low. Pretty unusual setup for that. So the normal one, if you want an accessory, is, we're going to call accessory number 1000, direction 0. So on your DCC handheld, I tend to have, if the track's turning left, it's a 0. If it's turning right, it's a 1. I know the NMRA have different ideas on that, but that's just the way I do it. The other thing that we're going to do while we're setting this up, we're going to set up 2 other items. I'm going to set 2 of these up on on pin 4, and I'm going to put in an accessory of 2, and what it's going to do is, if we turn right, so to speak, so if I send a 1, this time it's not going to send a pulse. So if I send, I send a left direction, it'll send the pin high. If I send a right direction, which is the 1, it'll send the pin low. So this would be the sort of thing that you would use for turning a set of building lights on and off. So this would be your sort of accessory, solenoid, and these ones are building lights on and building lights off. And that's it. That's all the code that is required to set up a standard pin accessory. Now, a standard pin accessory is always connected directly to the board. So if we bring back our camera, these are connected directly to the ESP32 up in this top corner just here, he says, trying to keep his fingers out of the way. Right, so that's standard accessories. Let's move on to the shift registers. So back on the Digital Town website, here is a sort of a schematic of a shift register in action. Now, each shift register can add you 8 more pins. So what I've done is I've numbered them, obviously 0 to 7. They're a little bit weird in that 0 is in this top position here, and then you start 1 to 7 on the bottom. The other thing is you have to define in nowRail which chip you're using, otherwise it won't know which set of pins. You can daisy chain virtually as many of these as you want. Now you'll notice in the diagram I've got a separate 5-volt power supply. This is the way that I would power the system on the layout. So 5 volts would be going to the VIN pin on the ESP32, but I'm actually driving these chips with a separate 5-volt supply. And the reason for that is if you start to add a number of relays, MOSFETs, all of these different things, you're going to start to chew through some power, and an ESP32 is not a power station. So you use a separate 5-volt supply to drive the power for all of these things. But obviously you do need to make sure that you have a common ground. So there are 3 pins that connect to the ESP32. I've put them up here. The yellow is the clock pin, the blue is the data pin, and the white is the latch pin. So if you just look at the wiring diagram, you'll be able to work that out, and you set that up in the function as you'll see in a minute. Now the other thing is the chip numbers. The way nowRail works is chip 0 is always the closest in the daisy chain to the ESP32, and then obviously you move on chip 1, chip 2, chip 3, chip 4, however many you want. At 8 items per chip, you can pretty quickly add a lot of items. So that is, if you like, the wiring circuit. Now let's get the code working. So what I'm going to do, I'm going to leave the 3 items in that we already have, and then we're going to set up the system. So let's just paste this function in, put our prefix on, and it takes the 3 pins that we set up in our wiring diagram. Now the board that I'm running at the moment is set up slightly different, so the latch pin is 14, the clock pin is 13, and the data pin is 12. Right, that's that bit done. Now once that's done, that initializes the system, so the system now knows we're going to be using these things. Right, now we need to add the individual items. So it's very, very similar to the adding a button. Again, we'll just copy this function over, put the prefix on, and I'm using only one chip, so I'm on chip 0. I'm going to be attaching this item to pin 0. This is the LED in the corner, and we're going to make it respond to accessory 1000. The direction it's going to respond to is 0. And because it's going to be an LED, I don't want a pulse, therefore I'm going to set that to 0. And the pin state for this one, I'm going to make it start by going to 0. So this turns off LED. Okay. I'm then going to copy that and do a second version. And this time I'm going to put a 1 in here for the opposite direction, and then I'm going to put a 1 in here because this time it's going to turn on the LED. It's as simple as that. That is now ready to go. So on your sort of handheld, set it one way, turn the lights off, set it the other way, turn the lights on. Next, what we're going to do is set up a pulse accessory decoder. So let's set this one up, and I'm going to set this one up on pin 4. I'm going to set it to an accessory of 1005. We are going to be responding to a left turn command from my point of view. I want it to be a pulse, and I want to send it high. So this sends a pulse. Now obviously that will turn accessory number 1005 in one direction. What about if I want to go the other way? Well, it's dead easy. So this time we're going to attach the item to pin 5. This is different to the way that building LEDs would work, because obviously building LEDs, you've got to turn them on, you've got to turn them off, so you're dealing with the same pin. Whereas with a solenoid, you're going to have one pulse that's going to go to one end of the solenoid, another pulse that's going to go to the opposite end. So you're going to need 2 relays or 2 MOSFETs per item. And so it's going to respond to the same accessory decoder address. This time it's going to be responding to a direction of 1. We want a pulse, and we want the pulse high. So this section here has set up either a that could be a relay or a MOSFET to drive one of these things. This is just controlling some lights, and that realistically is all there is to it. Now for the version that I've got running on the board at the moment, I'm just going to copy the code over completely so that you can see what I've done. So as you can see, I've got here some LEDs. That's the first LED, second LED, third LED, fourth LED. Those are all turning on and off. And then I've got my a pair of MOSFETs that would be controlling one turnout, and I've got a pair of relays that are controlling the other turnout. And that's all there is to it. Once that's done, you will finish up with this scenario, and you can see, if you watch carefully, you can see the little pulse that just came on. So the LEDs are remaining constant. The thing that's driving this is all being driven off time functions at the moment, rather than me pressing buttons. But as you can see, different items are flashing on and off. I've got some that activate together just to show that multiple items can run at once. So that's basically how it all works. I hope that's been useful, and if you've got any more questions on the nowRail system, I've had a few emails recently for different upgrades and stuff. Just let me know, and if you need any other specific tutorials, again, I can always add them later. I'm just trying to keep these tutorials as short as possible for now. So bye for now.